When x centimeters cube of solution of 0.5 molar magnesium nitrate were reacted with ammonium carbonate solution, the mass of magnesium carbonate formed was 8.4 grams. Write the ionic equation for the reaction that took place. So the ionic equation, I want to write first the overall equation, then from there we will write the ionic equation. So this is magnesium nitrate, which is reacting with ammonium carbonate, which is going to give us magnesium carbonate plus ammonium nitrate. This is a precipitating reaction. This is how we form insoluble salts. So magnesium is an insoluble salt as solid. This one is aqueous, and this one is aqueous. This one is aqueous. Let us balance the equation. We will put it to here so that we can balance the equation throughout. Now, this is not what we were asked to write. We were asked to write the ionic equation. We only write an ionic equation for the species that is forming the solid only. So the rest will be the spectator ions. So we just write what is forming the ions or the cations, and the anions forming the carbonate. The magnesium carbonate is magnesium and the carbonate ions. Therefore, ionic equation is that magnesium 2 positive aqueous plus the carbonate aqueous, which is forming magnesium carbonate as solid. So this is the expected response, and note this one. This one I was just trying to explain to you something. Calculate the value of x in this. So we want to calculate the value of x, but we have been given the mass of magnesium carbonate formed. If we have the mass of magnesium carbonate, we can get the number of moles of the sodium carbonate. So let us get the moles of magnesium carbonate formed equal to mass over Fm. Mass we have is 8.4 grams divided by the RFM. Magnesium is 24 plus 12 plus this, that is 84. So the number of moles is 0.1 moles. So this is the number of moles of magnesium carbonate formed. But from the equation you can see that the ratio for magnesium carbonate and the we want to calculate the and where is the, we want the X solution of magnesium. So we want the magnesium nitrate. So we are comparing this and this. The ratio is 1 to 1. You can see the ratio is 1, 1, meaning that the number of moles of magnesium carbonate, the number of moles of magnesium nitrate is the same. Since mole ratio of magnesium nitrate to that of magnesium carbonate is 1 to 1, moles of magnesium nitrate equal to 0.1. The ratio is 1 to 1. The ratio is 1 to 1. But we know that the 0.5 moles is the number of moles of magnesium nitrate in 1 liter, 1,000 centimeters cube. So we begin there. 0.5 is the number of moles of magnesium nitrate in 1 liter, 1,000 centimeters cube. We will ask 0.1 moles of the same will give us how many moles. So that one is 0.1 times 1000 divided by 0.5, and this one will give us 200 centimeters cube. So the value of X, the volume of magnesium nitrate that was used, is 200 centimeters. A certain carbonate, G carbonate, reacted with diluted hydrochloric acid according to the equation below. And this equation, we have been given the equation. The equation has been done for us. If 1 gram of the carbonate reacts completely with 20 centimeters cube of 1 molar hydrochloric acid, calculate the relative atomic mass of G. We want to calculate the relative atomic mass of G. So number of moles of HCl used, because the number of moles of we have this is in HCl, we have the molarity of HCl, we have the volume, so we can easily get the number of moles of HCl that was used. We know that the one is the number of moles, which is in 1000 centimeters cube. We will ask 20 centimeters cube of the same will contain how much or how many moles. So that is 20 times 1 divided by 1000. It's going to give us 0.02 moles of HCl. So moles of HCl used is 0.02. So we can automatically get the number of moles of the G carbonate from the equation. We can see the ratio is 1 to 2. Mole ratio, that is the carbonate, the G and the HCl is 1 to 2. So if the number of moles of the carbonate is twice, so the number of the carbonate is what? We are going to divide it by 2. So moles of the G carbonate is equal to a half times 0.02, which is equal to 0.01. But we want to calculate what? Calculate the relative atomic mass of G. So before we go at we must calculate first the RFM of G carbonate. So let me give you this triangle. I've always given this triangle. We have more. Okay, we have these moles. We have RFM. We have mass. Now we have the number of moles of the G carbonate. We want RFM. We have the mass, right? So RFM of the G carbonate equal to moles from here. RFM is equal to mass over moles. Mass over moles. Mass over RFM is equal to mass over moles. Mass is 1 divided by moles, which is 0.01. So the RFM is 100. Now, since we have the RFM, meaning that G carbonate, when you add every mass of each element, the answer should be 100. So G plus 12 plus 16 times 3, which is 48, will give us 100. G plus 60 will give us 100. So G equal to 100 minus 60, and that is 40. So the relative atomic mass of G is 40. When a hydrocarbon was completely burned in oxygen, 4.2 grams of carbon 4 oxide and 1.71 grams of water were formed. Determine the empirical formula of the hydrocarbon. You have been given the relative atomic masses of each. So first we know an hydrocarbon. So we have carbon 4 oxide formed. We have water formed after burning an hydrocarbon. But we are not interested with carbon 4. This what we are interested is carbon and hydrogen, because an hydrocarbon is an organic compound which contains carbon and hydrogen only. Therefore, let us get the mass of carbon from carbon dioxide. We get the mass of hydrogen from the water. So carbon itself is 12 over the total carbon, that is 12 plus 32, that is 44, and then times the total mass, which is 4.2. Now this one gives us the mass of carbon, and this one is going to be 1.145 grams. Similarly, let us get the mass of hydrogen from water. So water is, the total mass of water is 18, and hydrogen, there are 2 of them, so 1 plus 1 is 2, so 2 divided by 18 times the total mass, which is 1.71, we will get hydrogen, and the mass is 0.19 grams. Now we have the mass of carbon and the mass of hydrogen. Now we go back, element, the element here is carbon, another one is hydrogen. Mass in grams. Carbon is 1.145, hydrogen is 0.19. The next thing is the RAM. RAM of carbon is 12, hydrogen is 1. The next thing is the number of moles. How do you get moles? Moles is mass divided by RAM. Mass divided by RAM. RAM here, or RAM. So we have 0.095. This divided by this, you get 0.19. The next thing we want to calculate is the mole ratio. So the mole ratio, we divide by the number of moles which is smallest. So this one is smallest, is smaller than this one. Therefore, 0.095 divided by 0.0, we will get 1. Here we will get 2. So it means that carbon was 1 of it and hydrogen was 2, and that is the empirical formula of the hydrocarbon that was required. D gram of potassium hydroxide were dissolved in distilled water to make 100 centimeters cube of solution. 50 centimeters cube of solution required 50 centimeters of 2 molar nitric 5 acid for complete neutralization. Calculate the mass D of potassium hydroxide. Relative formula mass of potassium hydroxide is 56. So we have an equation here. The good thing is that you have written, that you have made our work easier by writing the equation for us. So we know that 50 centimeters cube of nitric acid, which has a molarity of 2, required 50 potassium hydroxide for complete neutralization. But now, since we have the molarity of the nitric acid, the volume, this is where we begin. We get the molarity, the number of moles that reacted. We say that 2 is the number of moles of nitric acid that are contained in 1000 centimeters cube. Now we want to ask 50, the volume that was used, will contain how many moles of nitric acid. So that is 50 times 2 divided by 1000. That one will give us 0.1 moles. Right? As you can see, the ratio from our equation is, the ratio is 1 to 1. The ratio is 1, 1, 1 everywhere. Meaning that, so mole ratio is 1 to 1. Meaning that moles of nitric acid will be equal to the moles of potassium hydroxide. So moles of potassium hydroxide equal to 0.1. Moles of potassium equal to 0.1. Right? So 50 centimeters cube of potassium hydroxide contains this number of moles, but the solution that was prepared, it is 100 centimeters cube. So let us get the number of moles in 100 of solution D, which is potassium hydroxide. So we will say 0.1 is the number of moles which are contained in 50 centimeters cube. What about 100 centimeters cube of the solution will contain how many moles? So it is 100 times 0.1 divided by 50, and this one will give us 0.2 moles. Now we have the number of moles of the solution that was prepared. Now the next thing is to calculate the mass. How do you get mass? Mass is equal to moles times RFM. The moles of the potassium hydroxide is 0.2, and the RFM we were given 56. So this times this will give you 1.2 grams. Next question. 20 centimeters cube of solution containing 4 grams per liter of sodium hydroxide was neutralized by 8.0 centimeters cube of dilute sulfuric acid. Calculate the concentration of sulfuric acid in moles per liter. In moles per liter. I want to do this for you in using two methods. So I will start with method number 1. So method 1. Method 1. First, as we know, every equation, every chemical reaction, write the equation, balance it for you to get the ratio, the mole ratio. That's the most important thing. So let us write the equation. Sodium hydroxide is reacting with sulfuric acid. Sodium sulfate plus water is formed. We will balance the equation. Now 4 grams is in 1 liter, so we will say 4 grams of sodium hydroxide was made in 1000 centimeters cube sodium hydroxide. We will want to know the mass in 20. So 20 centimeters cube will contain because the volume that was used is 20 centimeters of this was used. So we will get the mass, that is 20 times 4 divided by 1000, and that one will give us 0.08 grams. So this is the mass that was used. Now since we have mass, we can get the number of moles of sodium hydroxide. So moles of sodium hydroxide, is given by mass of RFM. The mass is 0.08 and the RFM is 40. And this one will give us 0.02 moles. Right? Now the ratio for sodium hydroxide and sulfuric acid, because remember the question is asking us calculate the concentration of sulfuric acid. Now we have the number of moles of sodium hydroxide that reacted with sulfuric acid. Since the ratio is 2 to 1, now we can get the number of moles of sulfuric acid. Now moles of sulfuric acid equal to, I have this number of moles, this one I have 0.02 times I have, and that one is 0.01 because the ratio is 1 to 2. Now we have the number of moles of sulfuric acid, but we know the volume of sulfuric acid that was used was neutralized by 8 centimeters cube cube dilute sulfuric acid. So we know this number of moles is in 8. So 0.01 moles of sulfuric acid are contained in 8 centimeters cube of volume. What will be the number of moles in 1,000 centimeters cube? Because we want concentration, molarity, concentration in 1 liter, moles in 1 liter per liter. So it is 1,000 times 0.01 divided by 8, and this one will give you 0.125 capital M. That is the molarity. Let us go to method 2 and see. Method 2, let us use this triangle here. Molarity RFM mass in grams per liter. Now we have the mass in grams per liter. 4 grams was dissolved to form a liter. Now we can calculate the molarity of sodium hydroxide used. So molarity is equal to mass which must be in grams per liter divided by RFM. We know the mass, that was 4 grams, and the RFM is 40. So the molarity of this sodium hydroxide that reacted with sulfuric acid is equal to 0.1 capital M. 0.1 capital M. Yes. Now next, we can now calculate the number of moles of sodium hydroxide that reacted with sulfuric acid. So we know the molarity of sulfuric acid. So we will say 0.1 is the number of moles of sodium hydroxide that are there in a liter, 1,000 centimeters cube. We will ask 20 centimeters cube will contain how many moles. So that one is 20 times 0.1 divided by 1,000, and that one is giving 0.002 moles. So this is the number of moles of sodium hydroxide that reacted with sulfuric acid. But from the equation we saw, the ratio is 1 to 2. So mole ratio of sodium hydroxide to sulfuric acid is 2 to 1, meaning that moles of sulfuric acid is equal to a half of this, 0.01 moles. So then we are going to say that 0.00 moles are contained in 8 centimeters cube of sulfuric acid. 1,000 centimeters cube will contain how many moles? 1,000 times 0.01 divided by, where did I get this one? This one is divided by 0.01. Yeah, there is a 0 here, 0.1. 0.01 divided by 8, and that one will give us 0.125. A weighed sample of crystalline sodium carbonate was heated in a crucible until there was no further change in mass. The mass of the sample reduced by 14.5%. Calculate the number of moles or N of water of crystallization in this salt. So we want to calculate the number of N, the number of water of crystallization in this water. So this one should be water. So first, we need to know initially when it had water of crystallization hydrated, it had 100%. Now after being heated, the mass reduced by 14.5%, meaning we have remained with anhydrous, which is now 85.5. So if you minus 14.5 here, you get 85.5. Now it means that the anhydrous sodium carbonate, the one that remained, is 85.5 after water, 14.5% water of crystallization evaporated. So having that in mind, now we have the element, the compound. The compound here is sodium carbonate, anhydrous, and then we have N waters. Mass by percent, this one is 85.5 and the water is 14.5. RFM, sodium is 106, water is 18. Number of moles, 85.5 divided by this, you will get 0.807. This one you will get 0.8056. The mole ratio is 1 to 1, meaning that the value of N here is 1. So N equal to 1. In an experiment, 30 centimeters cube of 0.1 molar sulfuric acid were reacted with 30 centimeters of 0.1 molar sodium hydroxide. Write an equation for the reaction that took place. The reaction that is sodium hydroxide with sulfuric acid. You need to balance the equation. Because you have been asked to write an equation, you must write the status, aqueous, and this is liquid water. It's water. State the observation that were made when both blue and red litmus paper were dipped into the mixture. This question can really be confusing because some students could imagine that 30 centimeters cube of 0.1 molar reacted completely with 30 centimeters cube of 0.1 because the molarity seems to be the same, the molarity is the same, the volume used is 30-30, therefore they could think that the reaction will go to completion and the neutralization product will be available. But on the contrary, first, for you to know the liquid with any reactant that was in excess, you must calculate the number of moles of each before you conclude. So first, let us see the number of moles of sodium hydroxide that reacted with sulfuric acid, and then we will be able to conclude. So first, moles, before we write the observation, you should know, is there any reactant that was in excess or not? Moles of sodium hydroxide used was, that is, you can get that one is 30 divided by 1000, which is equal to 0.03. So moles of sodium hydroxide is this one, right? And then moles of sulfuric acid that reacted with sodium hydroxide. Although we put this one, this was the one we were given, let us see the one that reacted with this 0.03 moles. The ratio is 1 to 1 to 2, meaning moles of sulfuric acid is a half. Right, but the number of moles of sulfuric acid that this one moles of sulfuric acid here was 0.03 moles sulfuric acid initially, right? So you can see the moles that reacted with sodium hydroxide is 0.015 reacted with 0.03, meaning now the acid was in excess. Therefore, you conclude that say that the blue litmus paper changes to red while red remains red. Give a reason for your answer in B above. The acid was in excess. And the end solution and the resultant solution was acidic. The resultant solution was acidic. Calculate the amount of calcium carbonate that would remain if 15 grams of calcium carbonate were reacted with 0.2 moles of hydrochloric acid. The equation for the reaction is shown below. So we have been given the equation there. We need to calculate the mass that remained. So we can also use two methods. Let us start with the first one. So moles of HCl we have been given 0.2 moles. Since the ratio is 1 to 2, so the carbonate and the acid, the ratio is 1 to 2. So moles of calcium carbonate is 0.1, a half of this, because the ratio is 1 to 2. Yes. Now, since we have the number of moles of the carbonate, we can get the mass. How do you get mass? Mass of the calcium carbonate used is equal to moles times RFM. So 0.1 times the RFM calcium carbonate, that is 40 plus 12 plus 48, that is 100 times 100. This one will give you 10 grams. So 10 grams was used, but initially the amount of calcium that was put to the reaction is 15. Therefore 10 has been used. How much gram that is remaining? How much gram that is remaining? That is 15 minus 10. 5 grams remained. That is the simplest way we can do it. We can also, that is method 1. There is another way you can do it. Let us do it method 2. Method 2 there. So we will say moles of HCl equal to 0.02. Therefore moles of calcium carbonate equal to 0.01 equals to 0.2, and this one will be 0.1, because the ratio is 1 to 2, right? The RFM of calcium carbonate equal to 100. Yes, so moles of calcium carbonate, the total equal to 15 over 100, and that is 0.15 moles, because they used the mass that was put to react with this one is 15. The mass that that was expected to react with the HCl is 15, but not all of it that reacted, right? So it is 0.15. So now we know the mass, the number of moles that reacted with the HCl is 0.1. We know the original moles was 0.015. Now we can get the difference, 0.15 minus 0.1 that reacted with HCl, we will get 0.05 moles. So this is the moles that was in excess, right? So mass equal to 100 RFM times 0.05, and this one will give you 5 grams. A compound has an empirical formula of C3H6 oxygen and a relative formula mass of 16. Determine its molecular formula. Determine its molecular formula. We know that mass of empirical formula times N will give us relative formula mass. Relative formula mass. That's what we know. Mass of an empirical formula times N will give us relative formula mass. So the empirical formula we have is C3H6O. We multiply this times N will give us the relative molecular mass, relative formula mass, which is 116. So this is 12 times 336 plus 642 plus 16. It will give us 58. 58n times 30. 58n is equal to 116. So divided by 58. Divided by 58, and the n equal to 2. So C3H6O times 2 will give us C6H12O2, and that is the molecular formula. Calculate the percentage composition of carbon by mass in the compound. So that we want to calculate the percentage of carbon only. So carbon, there are 6 of them. So 6 times 12. That one gives us 72. Divided by the total. The total molecular mass is 116 times 100. And that one will give us 62.07%. Zinc metal and hydrochloric acid reacts according to the equation below. This is the equation. 196 grams of zinc metal were reacted with 100 centimeters cube of 0.2 molar hydrochloric acid. Yes, what is the question? The question is determine. The question disappeared here. Determine. The question is determine the reagent that was in excess. So moles of HCl used, we can get 0.2 is the number of moles in 1 liter. We will ask 100 centimeters cube of the will contain how many moles? So it is 100 times 0.2 divided by 1000. That one will give us 0.02 moles, right? Now moles of zinc will be equal to, because we have the mass 1.96 divided by the RFM, because we have been given the RFM, which is 65.4. This one is 0.02997. But moles that reacted, moles of HCl or moles of HCl, moles of zinc that reacted with HCl is given, because the ratio is 1 to 2, so it will be a half. Moles of zinc that reacted with HCl is 0.01, right? Because the ratio is 1 to 2. Therefore, zinc was in excess. Zinc was in excess. Part B of question 16. Calculate the total volume of hydrogen gas that was liberated at STP. Zinc is this, and the volume at STP is 22.4 liters. We know any volume, any gas, hydrogen, the number of moles of hydrogen was 0.01. So 0.01 of hydrogen was produced. But we know that 1 mole of hydrogen gas at STP contains 2.4 liters. So we will ask 0.01 moles of this will contain how much? So 0.01 times 22.4 divided by 1. That one will give us 0.224 liters or 224 centimeters cube. In an experiment, 2.4 grams of sulfur was obtained by reacting hydrogen sulfide and chlorine gas as shown in the equation. Write which of the reactants act as a reducing agent in the above reaction. Explain. So hydrogen sulfide is the reducing. Hydrogen sulfide is the reducing agent because the oxidation number of sulfur increased from -2 to 0. So when you want to know the reactant, which is the reducing agent or oxidizing agent, for the oxidizing agent, oxidation will decrease. For if it is an oxidizing agent, the oxidation number will decrease to the right. If it is an reducing agent, the oxidation number will increase. So you just calculate the oxidation number and you will be able to see the one that is increasing is a reducing agent. The one that is decreasing is an oxidizing agent. Given that the yield of sulfur in the above reaction is 75%, calculate the number of moles of hydrogen sulfide gas used in the reaction. So there we say 75%. So what would be the number of what would be 100%? So 75% equal to 2.4 grams. So we want 100%. This one is equal to 3.2 grams. So moles of sulfur used equal to mass 3.2 divided by 32, and that one is 0.1. From the equation, the mole ratio of the sulfur and the hydrogen sulfide is 1:1. Mole ratio 1:1. So moles of hydrogen sulfide equal to 0.1 also. Calculate the number of moles. We have already finished that. .63 grams of lead powder was dissolved in excess nitric 5 acid to form lead nitrate solution, or the lead nitrate solution was reacted with sodium sulfate solution. Write an ionic equation. For the reaction between lead nitrate and sodium sulfate. So we are going to form lead sulfate. So we know then, therefore, the ionic equation is lead 2 ions aqueous plus the sulfate, which is going to form, which is aqueous, lead sulfate, which is a solid. That is, now you write it directly. Let us look at part B of the question. Part B, determine the mass of the lead salt formed in A above. The mass of lead that was formed. So moles of lead nitrate will be equal to 0.003. How? We can get the number of moles of lead first. So lead, the moles of lead is 0.63 divided by the RFM, because this is the mass that was used, 207, which will be 0.003. Right? Now, since these are the red ions, determine the mass of the red salt. So the ratio is 1:1. Therefore, we are going to get, this is moles, mass equal to moles times RFM. So the RFM of the red nitrate is 303. You add everything here, you get 303. So 0.03 times 303, you get 0.922 grams. Calculate the mass of nitrogen oxide gas that would occupy the same volume as 10 grams of hydrogen gas at same temperature and pressure. So there's nothing that's going to change. So moles of hydrogen equal to mass over RFM. The mass of hydrogen is 10. RFM of hydrogen is 2, so it is 5 moles. Moles of nitrogen 4 equal to 5 moles. Why? Because they are at the same temperature, pressure, right? So the number of moles of that would be. So what is RFM of nitrogen 2 equal to 46. So mass of nitrogen 4, this is nitrogen 4, of nitrogen 4 equal to 5 times 46, and that one is 230 grams. On complete combustion of a sample of hydrocarbon, 3.5 grams of carbon dioxide and 1.44 grams of water was formed. Determine the molecular formula of the hydrocarbon. It is like the one we did. So first, the mass of carbon equal to carbon in carbon dioxide is, that is carbon, which is 12 over the total, which is 44, times the mass, which is 3.52, and it's going to give us 0.96. In water we have hydrogen, and it is the hydrogen we want. So hydrogen equal to 2 in water over 18 times 1.44 is going to give us 0.16. Now we calculate the empirical formula element. Carbon, hydrogen, mass in grams. This one is 0.96, this one is 0.16. RAM is 12.1 moles. This one is 0.08 and this one is 0.16. Ratio, it is 1 to 2. So we will have CH2, but we have the molecular or the relative molecular mass to be 56. So we want to, so CH2 times N, the answer is 56. This one is 14N equal to 56. 50 by 14, 50 by 14. So N equal to 4. So CH2 4, it will give us C. It will give us C4H8, and that is the molecular formula. Thank you. Here, a solution was prepared, was made by dissolving 8.2 grams of calcium nitrate to give 2 liters of solution. Determine the concentration of nitrate ions in moles per liter. So first, let us calculate the RFM of calcium nitrate. RFM of calcium nitrate. So calcium we have been given, it is 40. Nitrogen times that is 14 times 2, 28. Oxygen, this is 16 times 3 times 2, which is 96. It will give us a total of 164 grams. That's 1 mole of calcium nitrate salt contains 164 grams in 1 mole. So 8.2 grams of calcium nitrate was dissolved. So let us get the number of moles that are present in 8.2 grams. We know how to get moles. Moles equal to mass divided by RFM. In this case, it is 8.2 divided by 164. This gives us 0.05 moles. Now we have the number of moles of the salt that was prepared. But remember, 8.2 grams prepared a solution 2 liters in 2,000 centimeters cube. That is 2 liters. So this number of moles are in 2 liters. but we want concentration of the nitrate ions per mole, per liter, right? It is per 2 liters. This is 2 liters. So we go on and say that 0.05, this is the number of moles present in 2 liters. 1 liter will contain how many? So it is 1 times 0.05 divided by 2, and this one will give us 0.025 moles. Calcium nitrate, because we have been asked to give the concentration of nitrate ions. It will give us calcium 2 positive plus nitrate. Yes, but the nitrate here, there are twice to balance it, there are twice 2 of them. So we have 2 moles of nitrate. So you can see now the ratio of the calcium to the nitrate is 1 to 2, 1 to 2. If the number of moles of the calcium is this one, what will be the number of the nitrate? So we say 1 equal to 0.025. 2 will give us what? 2 times 0.2025, and the answer is 0.05 moles per liter. So this is the number of moles of the nitrate ions in 1 liter. That is the molarity. 100 centimeters cube of 0.05 molar sulfuric acid were placed in a flask, and a small quantity of anhydrous sodium carbonate added. The mixture was boiled to expel all the carbon dioxide. 25 centimeters cube of the resulting solution required 18 centimeters cube of 0.1 molar sodium hydroxide solution to neutralize it. Calculate the mass of sodium carbonate added. 3 marks. So this question needs us first to write the equation of what happened here. So we have 2 equations that is happening here. The sodium carbonate first will react with the sulfuric acid 0.05 molar, and then the excess acid is going to react with sodium hydroxide. So let us go to the last equation, where sodium hydroxide is reacting with the excess sulfuric acid. To give us sodium sulfate plus water. Sodium sulfate plus water. So then let us balance the equation. That's what we have. We know that this one is 18 centimeters cube and the molarity is 0.1. 25 centimeters cube of this, so this one is 25 centimeters cube sulfuric acid that remained, which is reacting with sodium hydroxide. So first let us get the number of moles of sodium hydroxide, because here we have the molarity and we have the volume. So we can say that 0.1 is the number of moles in 1,000 centimeters cube of sodium hydroxide. Then 18 centimeters cube will contain how many? It is 18 times 0.1 divided by this, and it's going to give us 0.0018 moles. Yes. Next one, now we can get the number of moles of sulfuric acid that reacted with this. The ratio here is 2 to 1. So moles of sulfuric acid that reacted with sodium hydroxide is 0 0.0018 times a half, because the ratio is 1. The ratio is 2 to 1. So this one will give us 0.0009. This is the number of moles of sulfuric acid, the excess acid. But now this is the number of moles which is in 25, right? Now we remember 100 centimeters cube of 0.05 molar sulfuric acid was used. Therefore, for us to compare the excess acid with the original acid, we must get the number of moles in 100 centimeters cube, the excess acid. This one is the number of moles in 25 of the excess acid. So we say 0.0009 is the number of moles of which are in 25 centimeters cube sulfuric acid. 100 centimeters cube of this acid which was in excess will contain how many moles, so that now we can compare with this one. You cannot compare 25 with 100. Now this one is going to give us that is 100 times 0.0009 divided by 25, sorry, divided by 25, and it is going to give us 0.0036 moles. Yes. Now 0.036 moles, this is the number of moles that remained after reacting with the carbonate. So this is the number of moles of the sulfuric acid that remained after reacting with the carbonate. Now we know the number of we can now get the number of moles of the original and then subtract and see the number of moles of the sulfuric acid that reacted with the carbonate. So moles of the original is 0.05 is the number of moles in the original acid which are in 1000 centimeters cube. What is the number of moles in 100 centimeters cube of the original sulfuric acid? This one will give us 0.005 moles. But this one has remained after reacting with the carbonate. So we can get the number of moles of the sulfuric acid that reacted with the carbonate. So that is 0.005 minus what remained is 0.0036. Right? So this one is going to give us 0.0014 moles. And this is the number of moles of sulfuric acid that reacted with the carbonate. Now we can have the reaction with the sodium carbonate with sulfuric acid to get sodium sulfate plus water plus CO2 plus carbon dioxide. Yeah, sodium sulfate, water, and carbon dioxide is formed. The ratio of everything is 1 to 1. But we have the number of moles of sulfuric acid that reacted with the carbonate. Now we can get the number of moles of the carbonate. Therefore, this one is 0.0014. The ratio is 1 to 1. So moles of sodium carbonate equal to 0.0014 because the ratio is 1 to 1. The ratio is 1 to 1. Now, how do you get mass of a substance? Mass is given by moles times RFM. Now we have the mass of the carbonate, the moles of the carbonate. We can get the RFM from, we have been given the relative atomic mass of each. Therefore, sodium is 23. So out of sodium, 23 times 246 plus 12, 60 plus 48, 106. Therefore, 0.0014 times 106 will give us 0.148 4 grams of sodium carbonate that was used. Next question. When excess lead nitrate solution was added to a solution containing sodium chloride, the precipitate formed was found to weigh 5.56 grams. Determine the amount of sodium chloride in the solution. Determine the amount of sodium chloride in the solution. So first, you must know how to write the chemical equations of the compounds or of the substances involved in an equation. So here we are reacting lead nitrate. Lead nitrate is Pb nitrate is reacting with sodium chloride. This one will give us lead chloride, which is a precipitate, plus sodium plus sodium nitrate. We will put it 2 here because of this, and then we will balance here with the 2 here. So all of these are aqueous and this one is a solid. The rest are aqueous. The rest are aqueous. Now, we are told to determine the amount of sodium chloride. So first let us get the RFM of sodium chloride. Lead. Sodium chloride is in my mouth. Why? So determine the amount of sodium chloride. Yeah, sodium chloride. We want the sodium chloride. But now we will start with lead chloride, because the information we have is of lead chloride, because the precipitate lead chloride was formed. So it is from lead chloride we start, so that we can go back to calculating the mass of sodium chloride. So forgive me for the slipping of the tongue. Thank you. Now let us get the RFM of lead chloride first. So RFM of lead chloride equal to, we have been given 207 for lead. Chloride is 35 times 2, which is 71, and it's going to give us 278. Now, since we have the mass of the lead chloride that was formed, the precipitate, we can get the number of moles of the chloride that was formed, the lead chloride. Then moles equal to mass over RFM. Our mass is 5.5 divided by 278, and this one will give us 0.02 moles. 0.02 moles. Now the ratio, you can see the ratio of the sodium chloride and lead chloride is 2 to 1. So the mole ratio of sodium ions or sodium chloride to lead chloride is 2 to 1. But we have the number of moles of lead chloride, which is 0.02. So what will be the number of moles of sodium chloride? It will be twice. So 2 times 0.02, which is equal to 0.04, is the number of moles of sodium chloride. Next one now is to calculate the mass of sodium chloride. Mass of sodium chloride. How do you get mass? Mass equal to moles times RFM. So the RFM of sodium chloride is 35.5 plus 23, which is 58. So this one is 0.04 times 58.5. This is the RFM of sodium chloride. and this one will give us 2.34 grams. That is the mass of sodium chloride that was used. Next one is, when excess dilute hydrochloric acid was added to sodium sulfite, 960 centimeters cube of sulfur 4 oxide gas was produced. Calculate the mass of sodium sulfite that was used. The molar mass of sodium sulfite is this. The molar gas volume is 2 is this one, and the max is 3. So first, it is important to always to write equations everywhere some chemicals are reacting. So here HCl is reacting with sodium sulfite. So write the equation first. HCl is reacting with sodium sulfite, which will give us sodium chloride plus sulfur 4 plus water. So you need to balance the equation. We have sodium twice of 2 of them, and you have to put 2 here to balance the chloride ions. Now that is the equation. You can write the status. It is not necessary for now. So what is important, what we want here is the mole ratio. The mole ratio, you must balance the equation well as required. You must balance. So let us see. We know very well that 1 mole of any gas at STP will contain this. STP, RTP, I think you should know those, room temperature, and the other one is STP. So let us get the number of moles of sulfur 4. So moles of sulfur 4 is given by, we know very well that 24,000 centimeters cube is the volume which is in 1 mole of sulfur 4 gas. 1 mole. 1 mole of any gas contains this volume. So we will ask 96 centimeters cube. 960 centimeters cube would contain what number of moles? So we will get that this times divided by this, so it will be 24,000 divided by 9600, which will give 9610, that's 960, will give us 0.04. But we want to calculate the mass of sodium sulfite. What is the relationship in this equation? Now what we have is the mass of sulfur 4. The number of moles of sulfur 4. But now see from the equation we can see the relationship using the mole ratio. So this one, the ratio is 1 and 1 here, meaning that the number of moles of the sulfur 4 oxide gas will be equal to the number of moles of the sodium sulfite. Since mole ratio equal to 1 to 1, moles of sodium sulfite equal to 0.04. Now how do you get mass of a substance? So mass of sodium sulfite equal to its moles times its RFM. So moles, the moles is 0.04 times the RFM sodium sulfate. We have been given the molar mass. Molar mass is the same as RFM, relative formula mass. So it is 126. And this one gives us 5.04 grams. And that is the mass of sodium sulfite that was used or that reacted with sodium chloride. Maswali na majibu katika hadithi fupi ya mapambazuko na machweo. Mpaka sasa hukupata nafasi ya kunipigia simu au angalau kutuma harafa? Samahani, ulipopiga nilikuwa barabarani, singeweza kupokea simu.